In 2004, China captured the world's attention by relocating the 15,000-ton building from its original location. Without being demolished or dismantled, the entire structure was lifted off its foundation and slowly moved to a new site to make way for a new road. With a weight equivalent to thousands of automobiles, it remains one of the heaviest structures ever relocated intact in history. These buildings are designed to remain stationary for decades or even centuries. So how can engineers lift an entire building off its foundation and transport it to a completely different location while keeping its structure intact? Join Mandarin Tech as we explore one of the world's most unusual and impressive fields of engineering, the technology of whole building relocation. In fact, the idea of relocating entire structures has existed for a very long time throughout human history. Thousands of years ago, the ancient Egyptians used wooden sleds to transport massive stone blocks for the construction of the pyramids. By the 18th century, moving wooden houses with horse-drawn teams had become fairly common across Europe. In some Southeast Asian countries, such as Cambodia, local communities could even work together to lift and relocate entire traditional houses to new locations. By the late 19th century, specialized companies dedicated to lifting and moving buildings had begun to emerge in the United States, turning the practice into a true engineering discipline. However, as cities continued to expand, the scale of the challenge changed as well. Engineers were no longer moving only small wooden houses. They now had to deal with structures weighing thousands, and even tens of thousands, of tons while preserving their original structural integrity. And that is precisely what makes whole building relocation one of the most unusual fields of engineering in the world. Instead of constructing a new building from scratch, engineers find a way to make an entire building move. From the very first day it was built, every concrete column, load-bearing wall, and foundation was designed with one purpose: to remain firmly anchored to the ground for decades or even centuries. Yet through the power of modern technology, these towering reinforced concrete structures can be moved without affecting their structural integrity. To achieve this, engineers must find a way to separate the building from the place where it has stood for most of its life. All electrical systems, water lines, and utility connections are disconnected. Excavators then begin digging deep around the foundation, removing layer after layer of soil to expose the lower portions of the structure that have remained unseen since the day construction was completed. Once the foundation is exposed, construction crews create openings through the concrete. Massive steel beams are inserted beneath the structure from multiple directions and connected together into a load-bearing framework. Little by little, the weight of the building is transferred from the original foundation to the new steel frame. From that moment on, the structure is no longer truly standing on its original ground. Once the steel framework has taken on the full weight of the structure, the most daring phase of the project can finally begin. Dozens, and sometimes even hundreds, of hydraulic jacks are installed beneath the steel beam network. Each device occupies only a very small amount of space, but when operating simultaneously, they can generate lifting forces of thousands of tons. For large structures, the entire system is connected to a central control unit, transforming hundreds of individual jacks into a gigantic lifting machine that operates as a single coordinated system. What is remarkable is that engineers do not attempt to lift the building as quickly as possible. Instead, the structure is typically raised only a few millimeters at a time. After each small movement, sensors check the balance, pressure, and load distribution at every position before the next step can begin. Throughout the lifting process, computers continuously adjust the pressure inside each hydraulic jack to ensure that every part of the structure rises almost simultaneously. The allowable margin of error is often measured in millimeters. Little by little, a gap begins to appear between the structure and its original foundation. For the first time since the day it was built, the entire building is no longer standing on the ground, but is being suspended by a vast network of steel and hydraulic systems. The real challenge begins when the entire structure, weighing thousands of tons, must leave its original location and move forward. For projects that require only a short relocation distance, engineers typically install steel rail systems beneath the structure. Mounted on these rails are rollers or specialized hydraulic transport carts capable of carrying extremely heavy loads. As the hydraulic jacks begin to push, the entire building slowly slides forward like a gigantic train departing from a station. However, for projects that must cross streets, pass over bridges, or travel hundreds of meters to a new location, engineers must employ more sophisticated heavy-duty transportation systems. Beneath the structure are dozens of hydraulic wheel assemblies capable of rotating in multiple directions. Each assembly functions as part of an enormous invisible vehicle. They can raise and lower themselves, maintain balance, and continuously adjust their height while traveling across uneven terrain. Remarkably, the movement speed is usually very slow. Many structures advance only a few meters per hour. In return, the entire structure remains stable throughout the journey. In some projects, furniture, desks, chairs, and even other items inside the building remain untouched during the relocation. To prepare for such a move, transportation routes are often surveyed months in advance. Trees are trimmed, power lines are raised or temporarily removed, traffic is closed, and every obstacle along the route must be cleared away. Once the structure has been relocated to its new site, it is positioned precisely at the location determined in advance. Engineers then lower the structure onto its new foundation and carry out the final reinforcement work to ensure long-term structural stability. For most projects, the journey is nearly complete at this point. But in China, engineers have developed methods that make the relocation of an entire building far more flexible than ever before. In China, dense urban development has made many traditional building relocation methods difficult to apply. This has forced engineers to search for alternative solutions for structures located within extremely confined urban environments. As a result, an entirely new relocation technology emerged. Instead of finding ways to transport the building, engineers make the building move itself. In 2020, an 85-year-old primary school in Shanghai became the first structure in the world to use walking building technology on a real-world scale. The building had a T-shaped floor plan, a type of structure that is extremely difficult to relocate using conventional methods. If loads are distributed unevenly during transportation, the wings of the structure can experience deformation or cracking. Beneath the school, engineers installed nearly 200 hydraulic robotic legs. Each robotic leg was capable of lifting, lowering, and moving independently under computer control. The system was divided into multiple groups operating in sequence. While one group lifted the structure, the other moved forward. The two groups then switched roles. This cycle was repeated thousands of times, creating a movement that closely resembled human walking. Throughout the process, sensors continuously monitored the building's tilt, load distribution, and position in real time. The data was transmitted to a central control system, which adjusted each robotic leg with an accuracy measured in only a few millimeters. As a result, the entire structure could move and rotate simultaneously while maintaining balance. After 10 days of operation, the building had moved approximately 62 meters and rotated 21 degrees before being placed at its new location. This was not merely an ordinary building relocation project. It marked the first time a building had truly walked on robotic legs within an urban environment. In the building relocation industry, many projects have gone down in history because of their almost unimaginable scale and complexity. In 1999, the United States undertook one of the boldest projects in the history of construction. The Cape Hatteras Lighthouse, a 64-meter-tall structure that had stood along the Atlantic coast for more than a century, was gradually being threatened by coastal erosion. Without intervention, the entire structure risked being swallowed by the ocean. The chosen solution was not to build a replacement, but to move the entire lighthouse to a new location. Over the course of 23 days, the structure, weighing more than 4,000 tons, was relocated nearly 1 kilometer inland. It was the first time the global public had witnessed a structure of such scale being successfully relocated as a single piece. Many years later, American engineers once again demonstrated the capabilities of this technology by relocating the entire First Spiritualist Church in Springfield, Massachusetts. The historic red brick church was lifted from its foundation and transported through a dense urban environment using a multi-axle hydraulic wheel system. The project demonstrated that even structures more than a century old could be preserved and moved to a new location without being dismantled. However, as urbanization accelerated across China, the scale of relocation projects changed completely. In 2019, engineers in the city of Xiamen faced what seemed to be an impossible challenge: relocating a bus terminal weighing more than 30,000 tons as part of an urban redevelopment project. The structure was not only moved horizontally, but also rotated and transported along a curved path measuring approximately 288 meters. The project was later recognized by Guinness World Records as the largest structure ever relocated along the longest curved relocation route. These projects did more than establish engineering milestones. They revealed something even more remarkable. As cities continue to expand, the question is no longer whether a structure can be moved. Instead, the only remaining limit seems to be the scale of the next challenge engineers are willing to take on. For much of the 20th century, demolition was often the simplest option. When an old structure occupied land designated for a new project, excavators and explosives were usually the first things to arrive. But that approach is gradually changing. In many major cities around the world, the number of surviving historic structures continues to decline while their value continues to rise. An old building is more than concrete, steel, or brick. It is also a memory, an architectural landmark, and sometimes part of the identity of the surrounding area. At the same time, the pace of urban development continues to accelerate. New roads, subway systems, shopping centers, and modern financial districts are constantly expanding. Two needs that seem to be in conflict are increasingly occupying the same space: preserving the past and building the future. This is precisely why building relocation technology is attracting growing attention. Instead of choosing between preservation and demolition, engineers now have a third option. A structure can be preserved without necessarily remaining in its original location. The development of sensor systems, three-dimensional digital modeling, automated control systems, and hydraulic robots is also transforming the industry. Projects that were considered impossible only a few decades ago have now become reality. Structures are becoming larger, more complex, and capable of being relocated with greater precision than ever before. Beyond its role in preservation, building relocation technology offers significant practical benefits. In many cases, moving an existing structure can save considerable time and resources compared to demolishing it completely and constructing a new one from scratch. In some projects, engineers can even lift and transport an entire structure while furniture, desks, lighting fixtures, and many other items inside remain in their original positions. Thousands of tons of construction materials do not have to become waste, while the energy consumption and carbon emissions associated with new construction can also be reduced. This technology is also changing the way engineers think about the built environment. Rather than viewing the location of a structure as a fixed element, they are beginning to see it as something that can be adjusted when conditions change. A building no longer has to remain or disappear simply because of the place where it was originally constructed. Its greatest value lies in allowing cities to continue developing without completely sacrificing the remaining traces of their history. As technology continues to advance, the boundary between what can and cannot be moved is gradually expanding. Structures once considered too large, too heavy, or too complex to relocate may become entirely feasible projects in the future. In the past, urban development often meant demolishing what had existed before. Today, however, building relocation technology is creating a different approach. Instead of erasing the past to make way for the future, people can carry both forward on a new journey together. Behind these concrete structures, weighing thousands of tons, lies a simple yet powerful idea. Progress does not necessarily have to begin with demolition. Sometimes, rather than removing what has stood for decades or even centuries, people can choose to bring it forward into the future. If you enjoyed this video, don't forget to like and subscribe to the channel to join Mandarin Tech as we continue exploring some of the world's most impressive technologies, engineering projects, and construction achievements. Thank you for watching, and we'll see you in the next video.